Hello, good morning to you, beautiful students all over the world. Why I said all over the world because I don't know where you are now. Okay, so how are you doing today? I believe that you enjoyed your weekend. How was your test? By the way, I believe that you have seen your results, and if you haven't seen yours, you have to wait for it. However, let me be sincere with you. I am not really happy with your performance. Because only if you try to beat the average score. All right, please, I want you to do better this time around, and you have to follow all instructions. Try not to miss any lectures, and obey all your teacher's instructions. Okay, now please, I want you to get yourself settled. Ensure that you are not distracted. Okay, please take your writing materials if they need be, and let's get on with the class. Today we are going to look at the topic welding. Okay, we are looking at welding today. Welding. This is going to be an interesting topic. So you're welcome once again to my class. This is Yeged's class. Okay, I welcome you. So you are welcome. Okay? Our line objective for today this one, define welding. Two, state the methods used in welding. Three, state method of welding. Or and this, so you should be looking forward to answer all these questions at the end of the lessons. Now, what is welding? What is welding? Welding is an operation where two or more parts are united. Imagine, okay? The key word is united by means of heat or pressures or both. It is used usually on metals and thermoplastics, but can also be used on wood. Okay? So anytime you are thinking of welding, you don't think about metal alone because thermoplastics, what do you call plastic? Thermoplastic, woods can also be welded. All right. Now, let's now get to know other things we need to know about them. See, the parts that are joined are known as parent material. The parts that are joined are known as parent material. The material added to help form the joint is called filler or consumable. The form of these materials may see them referred to as parent plate or pipe, filler wire, consumable electrode. That is for arc welding process. Consumables are usually chosen to be similar in composition to the parent material. That means if you want to get the consumable or the filler, you must know the type of materials that are made of the parent materials. You will buy such material, okay, as your filler in order for the welding to be done effectively. So at the end of the day, you are going to have what we call homogeneous weld because the filler and the parent materials look the same way. But there are occasions, such as when welding brittle cast iron. So when a filler with a very different composition and therefore properties is used, then we have what we call heterogeneous. Now, the completed welded joint may be referred to as weldment. Joining metals. As opposed to brazing and soldering, we do not melt the base metal. Remember we talked about soldering, we talked about brazing. Okay? They do not melt the base metal. But when they involve a very high heat process, it does melt the base material. Okay? Now, the high heat causes a whirlpool of molten material which cools to form the joint, which can be stronger than the parent materials. Pressure can also be used to produce a weld, either alongside the heat all by itself. It can also use a shielding gas to protect the melted and filler metals from becoming contaminated or oxidized. Now, how do we join plastics? Okay, plastic welding also use heat to join the materials, although not in the case of solvent welding. And it's achieved in three stages. The first thing is that the solvents are prepared before heat and pressure is applied. And finally, the materials are allowed to cool to create fusion. Now, joining methods for plastic can be separated into external or internal heating methods depending on the exact process used. Now, how do we join wood? Okay, wood welding uses heat generated from friction to join the materials. The materials to be joined are subjected to a great deal of pressure before a linear friction movement creates heat to bond the workpieces together. Now, this is a fast process which allows wood to be joined without adhesives or smears in a matter of seconds. Now, look at this feature of a completed wedge. This type of wedge is both welding. We are going to be looking categorically at the type of welding in the next class. Okay, so you look at this. This is the parent material. Parent material, they are got broken, and you need to weld them. Here is the weld zone where you use the filler. Okay, the filler is applied there. Okay, and look at the root feature. You can see other features of these completed works which you can study on your own. Now look at some of the important things that you need to know when it comes to welding. Number one is that metal to be joined or surface by welding, braze welding, or brazing. That is what we call the metal. Then the filler, metal. Then metal added during welding, braze welding, brazing of surfaces. Then we have what we call weld metal parent, or metal melted during the making of a weld and retained in the weld. Now we have what we call HAZ, heat affected zone. So the part of the parent metal metallurgically affected by the weld or thermal cutting heat but not melted. Then we have what we call fusion line. It is the boundary between the weld metal and the HAZ in a fusion weld. This is a non-standard thing for weld junction. Then we have what we call weld zone. The zone containing the weld metal and HAZ. Now we have what we call weld root. Weld root. Zone on the side of the first run furthest from the welder. Then we have what we call weld toe. It's the boundary between a weld face and the parent metal or between runs. Then we have what we call weld face. The surface of a friction weld exposed on the side from which the weld has been made. Next, welding method. Now the first here is arc welding. Okay, arc welding. You know, this technique makes of filler materials, and they are used for joining metals like stainless steel, aluminum, nickel, and copper alloys, cobalt, and titanium. So arc welding process, you know, it is widely used in across the industry like oil and gas. You know, why oil and gas? You want to weld underground pipe line. Okay, they have to use that. Okay, even in power, in aerospace, in automotive, and much more, all these industries make use of arc welding. Okay, look at this person performing arc welding process. Now we have a friction welding process. Okay, we remember we talked about friction welding process. It is the process used for welding mostly wood. Okay. Now the mechanical friction generates heat which softens the materials which mix to create a bond as they cool. Friction welding does not require the use of filler metals, flux, or shielding gas. Take note of that. So friction is frequently used in aerospace applications and it is ideal for joining otherwise non-weldable light with aluminum alloys. Friction processes are used across industry and are also being explored as a method to bond wood without the use of adhesives or nails. Now, look at someone performing friction welding there. I think you can research more on that. Then we have about beam, electron beam welding. That's the third type of welding we're talking about now. Okay, this friction joining process uses a beam of high velocity electrons to join metals. Okay, the electron is being released under high kinetic energies, and during process, heat is generated along, and the heat of the impact on the workpiece cause the metals to melt together. The materials to melt together. Okay, there are many common applications for EBW, that's electron beam welding, as can be used to join thick sections. This means it can be applied across a number of industries from aerospace to nuclear power and automotive to rail. Now look at someone performing electron beam welding. Then laser is the last part. It's used to join thermoplastic or piece of metal. Okay, this process uses a laser to provide a concentrated heat ideal for barrel, deep welds, and high joining rates. So because it is automated, the high welding speed at which this process can be performed will make it perfect for high volume applications such as within the automotive industry. Laser beam welding can be performed in air rather than in a vacuum, such as with electron beam joining. Now look at laser beam. Now we have the last part, finally, the resistance welding. This is it is a fast process and is used in automotive industry. Okay, we have what we call resistance spot welding and resistance seam welding. They are the two types of resistance welding. Okay, and you can see that in spot welding, it is delivered between the two electrodes and which is applied to a small area as workpieces are clamped together. But in seam welding, it is also similar, but it's here it's the spot welding is it replaces the electrodes with rotating ways to deliver a continuous leak-free weld. Now look at those performing resistance welding. All right, looking at the lesson shelf for today. What can you say about all this? Let me see your answer. Send it across to me. All right. And dude, make sure you follow all these links so that you can get better out of it. Anyway, we have come to the lesson of today. If you're having any question, make sure you pass it across to me. Prepare for the class work, which will be coming up tomorrow. And make sure that you read very well. It's nice to be with you once again, virtually. And I hope very soon I'm going to see you in school. I've missed you. I believe you missed me. Have a wonderful day. Enjoy yourself.